All right, we're ready to tackle the power rule with the chain rule added on. So this is going to get a little bit juicy. It seems like students, when I meet them, and you as well, you probably already sort of know how to take derivatives. You're just confused by the chain rule. But that actually means you're probably good enough already. You could try working these along with me, like pause the video, work them, and then see how I work them. So if you're far enough along to try that, before even watching the video the first time, I would highly recommend it because practicing it and doing it yourself is the name of the game. The chain rule gets confusing because you're not sure, students are never sure when to stop using the chain rule, like to use it twice in the problem, 3 times in the problem. So it's like, that's what you need to get practice at, and you won't get practice at that if you only watch me do them. You still might get confused on your homework. And of course, when you're doing your homework, always check your answers in the back, because you're going to have some indecisive moments when you're trying to figure out how many times to do the chain rule or not. And the only way to check is to know what the right answer is and compare your answer to the back of the book. So that said, let's dive into the power rule. As you can see, we got a couple of problems here I mentioned in the last video that we could work without the chain rule. And that's if we had x, just a plain old x raised to a power, or if we had a plain old root of x, we're still okay, because that would just be x to the 1/3, which is really just a power of x. When we need the power rule, chain rule, is when when the exponent is on some stuff in parentheses. So like the number one way to spot this is if there's parentheses or something around a polynomial. Same thing here. This might not look like parentheses to a power, except this cube root is really just a 1/3 power on all this junk. So it's like you kind of scribble out this and just put a 1/3 power on it instead. Notice I use the word power, all of a sudden we're in the power rule. And the power rule is going to turn out as one of the easiest chain rule things to do. So you're going to find yourself wanting to convert things that aren't necessarily power rules into power rules. Just always, every problem you walk up to, sort of assume it's going to be a power rule unless something else happens. All right. So the new power rule, what is it? Well, here's the old one. And this is like in formula form, right? The derivative of x to any power would just be x to 1 less of that power. So take away 1 from the power, put the old exponent out front as a coefficient. So the derivative of x squared was just 2x to the 1. Check this out, the new power rule exactly the same. The derivative of anything, now u could be a function of x though, so the derivative of something to the nth power, once again it's going to be that same something to 1 less power, multiplied by the old power as a coefficient out front, so everything's totally the same still. The only difference is we're going to chunk on or add on this u prime. So what's u prime? It's just the derivative of whatever you were taking the power of to begin with. So let's take a look at some examples. This is just that same formula. I wrote it up here for reference. All right, so here, what is our u? We've got a power, so just walking up this problem like, okay, so that's something in parentheses raised to an exponent of 3. So right away I'm thinking, hey, got to use the power rule. The trick is, what's your u? What are you taking the derivative of raised to a power? And it's pretty obvious in this one that x minus 4 is going to be our u, because that's the thing that's being raised to the power of 3. So now I'm just going to plug and chug. Now, you don't have to label your u as u, but you might want to when you first start out, because that's what you want to be thinking, is when you walk up to a problem, you're going to think, hey, you figure out which rule you'd like to use. Like in this one, we're like, I want to use the power rule because there's a big power. But then you got to think to yourself, what's my u? And you got to make sure that that's all going to work out. Anyway, so you'll see what I mean in a bunch of examples. So we plug and chug. Says the derivative of u to the n is going to be n, so the old exponent. So let's write that down first. That's the 3, so we're just going to put that right here. Then we've got u again, only to a new power. So it's going to be the same stuff, just raised to 1 less power. So x minus 4 still, and then to the n minus 1, which is 2. All right, and then the thing you don't want to forget, but like the number one way to get these problems wrong is to forget u prime. So what is u prime? Well, it's just a derivative of, in this case, x minus 4. Not too bad, right? So what's the derivative of x minus 4, our u? Well, the derivative of x minus 4 is just 1, because the derivative of negative 4 is 0, since it's a constant. Derivative of x is just 1. All right, so that's no big deal. Let me just get 3 times x minus 4 squared. Good stuff. Now, you don't really want to be doing any of this in head, so you'll see that I kind of do an extra step in there. which might be annoying to some, but hey. All right, so this one is just a little bit different. It's got a 2 out front, but what do we do with coefficients in front of powers or whatever? It doesn't matter, right? You just leave the coefficient alone. So we're going to leave that 2 out front. Now we're going to do the power rule. Looks like this is our u. Now that 2 is not part of our u because it's not being raised to the exponent. This exponent of 5 only applies to the stuff in parentheses, which means the stuff in parentheses is our u. So what's the formula? Take the old exponent, which is 5. Then we're going to put u, again, same as it was. Then we're going to raise it to a new power, which is just 1 less than the old power. So 5 minus 1 is 4. And now we don't want to forget our u prime. So what's the derivative of our u, which in this case is x squared plus 3? Derivative of x squared plus 3, the 3 derivative is 0. Derivative of x squared is 2x. All right, so you can, now if you just left your answer like that, it's kind of an algebraic mess. If I was your teacher, I would take off a point. Seems like, most teachers will not give full credit unless you at least, simplify a little bit. So let's take a look. We got 10 right here. So these guys go to 10 times 2x. So we got a total of 20x. And it's usually good form to put everything in front. So if you have some x's and some coefficients and stuff, you just put those all in front in one term, and then you have your thing raised to the power second. That's kind of like the best looking way to write down a power rule answer. Or chain rule, chain rule in general. You're always going to end up with that u prime, but usually you actually want to leave that u prime out front by the time you're done. All right, why is this a negative exponent problem? Well, we've got a power, except it's in the denominator. So you might be thinking, oh man, I got to use the quotient rule. What a headache. Well, you don't actually have to, because we could rewrite this as x minus 4 to the negative 3 power. And once you got it written as something in parentheses to a power, yay, it's a power rule situation. And of course, this x minus 4 is our u. So what's the formula? Take the old exponent, keep our u the same. Then we got to subtract 1 from the old power. But what's negative 3 minus 1? It's actually negative 4, which is sort of counterintuitive. When you have a negative exponent and you take the derivative, the exponent actually gets bigger looking. I mean, to me, a negative 4 looks like a bigger number than negative 3. But you just got to remember that negative 4 is actually less than negative 3. It's to the left on the number line. So that's why those are confusing. And then lastly, you do not want to forget your u prime, which in this case turns out to be pretty easy because derivative of x minus 4 is just 1. All right, so we can pretty much just scribble that out, and there's our answer. So that is nice. When the derivative of your u is just 1, turns out we almost didn't need the power rule on this. And we did, but at least u prime didn't throw us any curveballs. All right, so this last one, the second one, why is that a negative power? Well, once again, we could be doing a u prime chain rule situation on this. All right, so we got, gonna rewrite this as 4 times x minus 2, and that's the negative 1, all raised to the 5th power. Now this is still not really quite a power rule because I got this weird thing where I got an exponent outside another exponent. So what I need to do is distribute in this 5 and get us down to 1 exponent. So I got to distribute this to this term and to that term. So it's going to be the derivative now. Remember, this is all prime. So d over dx of 4 to the 5th times x minus 2. And then when we raise an exponent to an exponent, we multiply. So this is going to be a negative 5. Negative 1 times 5 is negative 5. It's our exponent. All right, so now this does look like a power rule. You might be thinking it looks like a product rule because we've got 4 to the 5th times x minus 2 to the 5th, the negative 5th. But the reason it's not is because this is just a number. It's just a coefficient. So we can just jump right into the power rule and just leave our 4 to the 5th alone. I don't know what 4 to the 5th is. I mean, that's a big number. Get on your calculator or whatever. You could probably just leave it in the answer, and your teacher wouldn't give you too hard a time. All right, so we're going to leave that coefficient alone. Now we go to the power rule. So we take the old power and make that a coefficient. So negative 5. I put that in parentheses because it's a negative number, and I don't want to mess up. It's usually better if you're plugging negative numbers, just put them in parentheses so you remember its multiplication. All right, so that's our old power. Then we got x minus 2. And our new power is negative 5 minus 1, which is negative 6. Then we got to multiply by the derivative of u prime. And of course our u, now see, this was kind of interesting. If you look back at this stage of the problem when we first got it, you probably would have thought our u was 4 over x minus 2. But that's not the u we're going to use. The u we need to use is the one we had right before when we executed the power rule. And by that time we had x minus 2 to the negative fifth. So x minus 2 is our u. So the derivative of that is just 1. Alright, so we're pretty much done here. Unless I felt like going into a calculator and expanding that 4 to the fifth, whatever giant number it is, there's sort of no point. So there you go. Well, let's take a look at the next slide of problems. Alright, what if our u is a trig function? Now, I mentioned this before that when you have a 3 on a sign of something, really that's a power rule situation. Because if you rewrite this, this is really the sine of x raised to the third power. So doesn't the sine x all of a sudden look like my u? Because it's the thing that's getting raised to a third power? Yeah, so we can still use the power rule. That's awesome. We just got to realize that the sine x is just going to come in as our u prime term. We're not going to start off with a sine or cosine derivative. Because usually when you see this, you might be tempted to say, oh, sine or cosine. Let's use our sine or cosine. You know, the derivative of a sine is cosine, and derivative of cosine is negative sine, or whatever. But this is not really a trig function. It's really a power rule situation that happens to have a trig function in it. Because the first thing we see is the exponent. The most outermost set of parentheses has an exponent on it, so we got to start with a power rule. Now all we do is we take the old exponent, put it out front, so that's 3. Then we keep our u, which is sine x. And I'll just keep writing it in this wacky parenthesis form. Make it obvious what I'm doing. Alright, so we reduce the exponent by 1. Now we just got to multiply by u prime. So since our u was sine x, our u prime is cosine x. Pretty good. So now just finally I'll rewrite this in a slightly better looking way. Because you know sine x quantity squared, this whole term, that's usually written as sine squared x times cosine x. Alright, not too shabby. Well, let's take a look at the next one. So once again, this is actually a power rule first and foremost, because you could rewrite this as 2 times tan x to the fifth power, just to make it more obvious. Once you get good at these, you'll just sort of realize, oh, that's a power rule, and you won't bother rewriting it with parentheses like this. Alright, so we're taking the derivative of this junk. That 2 out front is just a number, so we leave it alone, so we just leave it 2. Now the derivative of tan to the fifth is going to be 5 tangent to the fourth, because we reduced the power by 1. Now we got to multiply by the derivative of u, because our last step in all these power rule problems, all chain rule problems in general, is to multiply by u prime. So what's u prime? Well, let's see. This is our u right here. So that means the derivative of tangent is our u prime. Tangent is secant squared. Alright, so we end up with 2 times 5 is 10. Tangent to the fourth x times secant squared x. Now when you notice I dropped these dots in here when I'm multiplying stuff together, these can get confusing, so it's just like when in doubt, you might as well put a little dot in there. It's not going to hurt anything, and it makes it really super obvious that it's not the tangent of secant and all that junk. There's just tan x, and then secant x is a separate term that's being multiplied. Alright, common mistake. Now this looks like a really gentle power rule problem. There's just going to be a negative sign in the middle of it, because if you look at your u prime, what's it going to be? This is probably our u. So the derivative of 2 minus x, you know, once you get fast at the power rule, you look at that 2 minus x and say, oh, the derivative of x is just 1. But it's actually negative 1. Our u prime is going to be negative 1 because there's a negative in front of the x. So that's what's going to be tricky about this one. We'll still apply the power rule the same way. We just want to be really careful when you get your u prime. So 3 goes out front as part of the power rule. So 3, 2 minus x to the 1 less power, which is 2. Now we're going to multiply by u prime, which is, I was saying, if your u is 2 minus x, that means your u prime is negative 1. And again, when I put negative numbers in, I always put them in parentheses, so it's totally obvious that it's not just like subtracting 1, it's multiplying by negative 1. And that's going to give us negative 3 times 2 minus x squared. All right, last one. You'll notice this is on a page about watching your negatives, and yet I do not see any negatives on this thing. Let's see what happens. All right, looks like a pretty straightforward power rule situation where this is going to be our u, right? Because it's just something raised to a power 2. So it seems like a no-brainer. Let's take a crack at it. Take the old exponent, put it out front. So we'll get 2 times 4 plus 1 over x. Our new power is 2 minus 1, which is 1. And then what's our u prime? This is where things get a little dicey. Because what's the derivative of 4 plus 1 over x? I don't know. 4, I know the derivative of 4 is just 0 because it's a constant. But what's the derivative of 1 over x? Well, now I'm going to want to go off to the side and do a little bit of work, off to the side so that I know what to plug in for u prime. So if what's the derivative of 1 over x? A little prime to indicate we're taking the derivative of that. So what is it? Well, we got to convert x. Anytime you have x downstairs, the easiest way to do it is just to move it upstairs and give it a negative exponent. So this is going to be the derivative of x to the minus 1, which we got to do the power rule on x to the minus 1 to take its derivative. So it's going to be old exponent times x to the new exponent, which is 1 less, which is negative 2. So there's the negative sign I was talking about. So the derivative of our u prime, going back to this example, here was u. Turns out our u prime is negative x to the minus 2. So you can see how that was a little bit, we got a negative sign out of it, and it's a little bit confusing. So when I'll just take this negative sign and move it out front. So we'll get negative 2 times 4 plus 1 over x, and then times x to the minus 2, but really that's just x squared downstairs. All right, so teachers vary and books vary on how simplified they expect you to make stuff. Do we need to go through here and try and reduce some terms, or I don't know what you want to do. I tend to leave things, unless there's a really obvious way to simplify it, I would say just leave it alone, let it ride. Don't go to too much trouble to make it look pretty. All right, so that was the power rule in a nutshell. Now those weren't like hard chain rule problems. Those were sort of middle of the road power rule chain rule problems. If you have an easier class, no calculus is easy, but if you don't have one of the worst classes like AP at a hard school or something, then that's probably in the ballpark of how hard the power rule is going to get. You'll see a lot of different versions though. You'll see it with more trig functions and exponentials and stuff. So stick around for the next videos because we're going to keep recycling the power rule. It's like by far the most common derivative you have to take with a chain rule. So, every other video we work in this chapter and in this class on this website, totally, we're going to use the power rule again and again and again. So don't feel like you have to know it completely right now because you're going to get so much practice as we go forward.